This is lesson 1-7, function notation. Our warm-up today, we have plugging in values for x. So 5x minus 2, we're going to plug in 4. So 5 times 4 minus 2, 20 minus 2, which is 18. 2, we're going to plug in 5. So 5 squared, 4 times 5 minus 1, we get 25 times 3, which is 75, plus 20 minus 1, which is 94. Plug in 16, we get 2 times 16 plus 4 times square root of 16. That is 32 plus 4 times 4, which is 16, which is 48. Some sets of ordered pairs can be described by using an equation. When the set of ordered pairs described by an equation satisfies the definition of a function, the equation can be written in function notation. Here's an example of function notation. Basically, the f of x takes the place of y, 5x plus 3. So f of x equals 5 times x plus 3. The function described by f of x equals 5x plus 3 is the same as the function described by y equals 5x plus 3. Both are the same. F does not mean f times x, f multiplied by x, so don't get that confused. This is f of x, the value of x. Here's some examples. So if I want you to evaluate f of 0, f of a half, and f of negative 2. Those are 3 different answers, 3 different equations that you have to set up. So we're going to plug in 0 first. So 8 plus 4 times 0 is 8. So f of 0 equals 8. Then we're going to plug in a half. So f of a half is equal to 8 plus 4 times half. 8 plus half of 4, which is 2, equals 10. And then we're going to plug in a negative 2. So 8 plus 4 times negative 2, it's in the green, is 8 minus 8, which is 0. Those are my 3 answers. The next one is a little bit different. It's a graph. So the graph, what you're going to do is, remember f of 0, this is the x value. So we're going to go to the 0 on the x-axis, which is right here. And you want to know where it hits your red line. So it hits it up here at y equals 3. So 0, 3, my f is 0, my y is 3. F of a half. So again, go on the x-axis, look for a half, and the red line crosses there. So this is 1/2, comma 0, so 0 is my y value. Negative 2. Negative 2 on the x, go all the way up. It hits the graph, the red graph at 4. So 4 is my answer. These are plugging it into the equation again. So f of 0, you plug it in, you get 0. Plug in f of a half, you get negative 1 3/4. Plug in negative 2, we get 12. If they want you to graph the function, there's 2 types of graphs. There's where they give you just a set of points, nothing in between them, no decimals, no anything else. You are just going to graph those individual points. So 1, 2, 3, 4, 5. I should have 5 dots on my graph. Do not connect them, because if you connect them, it means it includes the values in between. Do not connect them. That's my picture. Function whose graph is made up of unconnected points is called a discrete function. Now, if the graph is f of x equals 3x minus 1, and you are picking the points, they don't give you a set table of them. You are picking the points, so you could pick positives, negatives, decimals, fractions, whatever. Then you will connect the points because it's a continuous. It means all of the points on that line. So I made a t-chart, and then I plugged in 0. I got negative 1. I plugged in 1. I got 2. Plugged in negative 1, and I got negative 4. And again, you can choose any numbers you want for your x values. Plotted my points, connected into a line, and make sure you have arrows on it because it continues in both directions. This last question, again, these are set points, so we are going to plot set points on that graph. And that's it for lesson 1.7.